Welcome to today's deep dive. Our mission today is to provide you with a highly professional, densely informative exploration of the RICS practice information regarding construction change control and management.
Thanks for having me. And yeah, it's a massive topic.
It really is. And I see you've already got your digital blueprints pulled up on the monitor there, and I spot the hard hat sitting on the bookshelf right behind you.
Oh, yeah. I was just making some notes on the guidance before we started. I mean, looking at the sheer volume of the RICS documentation we pulled for this session, it's immediately clear why project teams get bogged down.
Yeah, totally.
But the overarching principle you need to keep front of mind today is that knowledge of these change control systems is only valuable when applied proactively. Knowing the contractual mechanisms is just the baseline. Deploying them effectively in real time is what actually saves a project from going under.
Okay, let's unpack this. Because right out of the gate, the source material makes a fundamental distinction that it seems to get blurred constantly in practice.
Oh, all the time.
It separates the concepts of change control and change management. We hear those terms used interchangeably on site, but they describe two very different functions.
Right.
To use an analogy, think of change control as the mechanics of a vehicle. So the steering wheel, the brakes, the transmission, it's the formal process, the paperwork, the strict mechanisms that legally alter the timeline, the cost, or the scope.
Exactly.
Whereas change management, on the other hand, is the driver actually navigating the road. It involves the human element, the site implementation, and the strategy to ensure that once a change is accepted, the project actually benefits from it, or at least suffers minimal disruption.
What's fascinating here is why that distinction matters so intensely on the ground. If you mismanage the control process, if you don't adhere strictly to the contractual mechanisms for notifying a change, you derail the project's entire risk profile.
Because you lose your legal footing.
Precisely. The control process is the legal shield for both parties, but the management process is what physically gets the asset built despite the alterations.
Yeah, that makes sense.
If a project manager approves a major change in scope, without actually managing how that impacts the sequencing of the mechanical and electrical trades on site, the control mechanism was successful, but the management failed completely.
And the result is a project that bleeds money through delays and out-of-sequence working.
Spot on.
So control is your legal protection, and management is your actual execution. But a major part of that execution involves anticipation, right? You can't manage change effectively if you haven't anticipated the risks that force those changes in the first place.
No, you can't. You're just flying blind.
Which brings us to the risk register. In practice, risk registers often just end up as a compliance document sitting in a drawer. How does the RICS guidance say they should actually function to protect the commercial viability of a project?
Well, the guidance is very strict about the minimum requirements for a robust risk register. It moves it far away from being just a list of bad things that might happen.
Right, not just a worry list.
Exactly. As a minimum, you must explicitly name the risk, assign a specific percentage probability to it, establish a planned, actionable response for managing that risk, and put provisions in place for continuous monitoring. It has to be a living, breathing document that is updated at every progress meeting.
But how does that actually translate to the project's bottom line? Because clients always want to know exactly how much contingency they need, and they usually just want to throw a flat 10% at it and call it a day.
And that is exactly the habit the guidance aims to break. The RICS categorizes risks to help you structure a mathematically sound contingency fund. You have design development risks, which reflect the danger of changes in estimating data or third-party approvals during that design phase.
Okay.
Then you have construction risks, which cover unforeseen site conditions, weather events, or supply chain failures once you actually break ground. And finally, you have employer change risks, which account for the employer simply altering their mind or their requirements. As a professional, your contingency funds must be tied directly to these identified risks and their assigned probabilities.
So you calculate the potential cost of the risk?
Multiply it by the probability percentage, yeah.
Got it.
And that forms your contingency. It shifts the entire mindset from guessing to calculating.
So you are building a contingency based on mathematical probability rather than just a slush fund.
Exactly.
But a risk register is ultimately an internal management tool. How do these calculations and anticipated changes survive contact with the actual legally binding contracts? Here's where it gets really interesting, because the major contract suites handle changes using completely different philosophies.
They absolutely do.
If you don't know the specific language and mechanics of the contract you're using, you are going to get lost in translation very quickly. So let's start with the Joint Contracts Tribunal, or JCT.
Under the JCT suite of contracts, changes are referred to as variations. A defining characteristic of JCT is how it handles the fallout of a variation. It generally evaluates time and cost on completely separate tracks.
Interesting.
Yeah, if the employer alters the design, quality, or quantity of the works, you look at the direct cost implication of that work. Then, almost as a separate exercise, you evaluate if a relevant event has occurred that warrants an extension of time, and if a relevant matter has occurred that entitles the contractor to loss and expense.
That separation seems like it could lead to really disjointed negotiations. But the risk allocation under JCT also shifts dramatically depending on the specific form you use, right? How does that play out in a real-world scenario, say, if the site conditions are completely different than what was assumed?
Let's look at a concrete scenario. Imagine a project where the initial soil report completely missed a massive band of rock right where the foundations need to go.
A nightmare scenario.
Oh, absolute nightmare. Now, if you are using a JCT standard building contract without quantities, where the employer provides the full design, the employer generally carries the risk for that design.
Okay.
So the employer would have to issue a variation to change the foundation design to deal with the rock, and they would bear the cost and time implications. However, if you are under a JCT design and build contract, the dynamics flip.
Because the contractor takes the design lead.
Exactly. The employer provides their requirements, but the contractor produces the design and usually takes responsibility for verifying the site conditions. In that D&B scenario, when they hit that rock, the contractor usually swallows the cost of redesigning the foundations and the delay.
Because they took on the design responsibility. They take on the commercial risk of the site conditions.
Precisely. Though it is worth noting that under design and build, the contractor can also propose changes that benefit them. They might find a more economical structural solution that still meets the employer's requirements, and they can potentially retain the benefit of those cost savings.
That structural separation of time and cost in JCT is a stark contrast to our next major suite, the new engineering contract, or NEC. NEC just throws the JCT playbook right out the window.
It really does. It's a totally different culture.
It calls changes compensation events, and it forces the parties to deal with time and cost together as one holistic package. The contractor prepares a quotation that encompasses both the financial cost and any delay to the completion date and presents it to the project manager.
That holistic approach is the defining philosophy of NEC. It forces the parties to agree on the total impact of a change before the work is done, providing the employer with cost certainty. And this ties directly into one of the most powerful tools in modern construction management, the early warning notice, or EWN.
Right, the EWN.
The EWN process is designed to bring the project manager and the contractor to the table to mitigate issues before they explode into massive compensation events. If either party becomes aware of anything that could delay the project, increase costs, or affect performance, they are contractually obligated to issue an early warning notice.
But in the real world, no contractor wants to raise their hand and admit there's a delay brewing or that they might have underpriced an element. I mean, they usually want to try and fix it quietly to protect their margin. What actually forces them to issue this early warning notice instead of just hiding the problem?
The NEC suite has a very sharp stick to enforce collaboration.
Mhm.
If you are working under an unamended NEC contract and a contractor fails to issue an early warning notice for an event they were aware of, the project manager assesses the resulting compensation event as if the contractor had given the early warning.
Meaning what, practically?
Meaning that if the project manager could have mitigated the delay or found a cheaper solution had they been notified early, the contractor is only paid for that cheaper mitigated solution.
Wow.
Yeah. The extra costs they incurred by hiding the problem and letting it escalate are entirely disallowed. It forces the contractor's hand. You don't hide a problem and hope to claim for it later. You flag it immediately so the team can manage it, because if you don't, you foot the bill for your own silence.
That is a brutal but highly effective mechanism. Now, you mentioned unamended NEC contracts. That is a crucial distinction for anyone managing these projects because employers almost always amend these standard contracts with Z clauses to shift the risk heavily back onto the contractor,
Oh, absolutely.
sometimes neutralizing the collaborative intent of the EWN entirely.
That is a very common reality. You have to read the Z clauses because they often completely rewrite the rules of engagement.
Okay, so we have JCT separating time and cost, and NEC forcing holistic proactive management. To round out the big three, we have FEIC, the International Federation of Consulting Engineers. Now, FEIC is a massive player on the international stage, especially for heavy infrastructure. How does its philosophy differ?
FEGIC takes a completely different, heavily engineer-led approach. Like JCT, it uses the term variations, but the contract designates an engineer capital E who acts as the employer's agent and has sweeping authority to instruct variations at any time before the taking over certificate is issued. A defining characteristic of the FIDIC Red Book is its use of approximate measured quantities.
Let's define that clearly for the listener, because it really changes the commercial baseline of the project.
Simply put, under this mechanism, you do not lock in a fixed lump sum for the entire project up front.
Right.
Instead, the bills of quantities contain estimated volumes. Say you estimate that you will need 10,000 cubic meters of concrete, and the contractor provides a rate for that specific volume. You are paid based on the actual physical remeasurement of the work done. If you actually end up pouring 12,000 cubic meters, you are paid for 12,000 at that agreed rate.
But what happens if the volume changes so drastically that the original rate is no longer commercially viable? I mean, pouring an extra 200 cubic meters is one thing, but pouring an extra 10,000 changes your economies of scale entirely.
And that is exactly where the power of the engineer comes in. If a variation is instructed, or if the actual volume of work simply differs from the approximate quantities in a way that fundamentally throws the balance of the contract rate off, the engineer has the authority to adjust those rates.
Oh, I see.
Yeah, it provides a structured mechanism to ensure fairness when the actual ground conditions or the reality of the execution differ significantly from the initial estimates.
So we've covered the legal frameworks, but the actual physical mechanics of calculating these changes have shifted radically too. And I don't mean just moving from 2D paper drawings to 3D models. As industry professionals, you already know what building information modeling, or BIM, is. The real focus here is how BIM alters the claims and change management process entirely.
If we connect this to the bigger picture, BIM fundamentally shifts the battleground of cost planning and change management. In a traditional 2D bill of quantities setup, any design variation means a quantity surveyor has to manually remeasure the affected areas, recalculate the volumes, and present the new numbers.
With a scale ruler and a highlighter.
Exactly. It is incredibly time-consuming, and the argument between the employer's QS and the contractor's QS usually centers on the accuracy of those measurements. But with a mature BIM model, you have an automated process called a quantity takeoff, or a QTO.
Because the 3D model is essentially just a massive database of structured data.
Precisely. When an architect proposes a design change, say, swapping out a specific type of steel framing across a 10-story building, the BIM software automatically updates the quantity takeoff. The argument over how much extra material is needed is practically eliminated because the software dictates the volume based on the geometry.
That's incredible.
The project team can swiftly assess alternative design proposals and immediately see the spatial and material impact.
Which means the commercial debate shifts entirely. If you aren't spending a week arguing over the volume of steel with a scale ruler, what are you negotiating?
You are negotiating the rate and the time extension. The QS transitions from being a human calculator to a strategic negotiator. You are arguing over the impact that the new steel framing has on the procurement schedule, the crane lifting times, and the sequencing of the follow-on trades. The math is automated, so the human expertise is applied to the logistics and the contract strategy.
The source material also highlights how this shared data environment streamlines site queries. When issues pop up on site, you can integrate requests for information RFIs directly into the model.
Yes, that's a huge benefit.
Instead of a detached, confusing email chain trying to describe a pipe clashing with a beam on level 4, the RFI is pinned to the exact 3D component in the model. The design team sees exactly what the contractor sees, producing an integrated response that prevents delays and keeps the supply chain moving.
That level of digital integration is critical, but it places a heavy burden on the professional. A technology calculates the quantities, but the human being has to navigate the contractual realities. That brings us to what the RICS expects as a minimum level of service from a professional quantity surveyor or project manager.
It's not just running the software.
Far from it. It is not enough to just use the software and forward the automated QTO to the client. You are expected to apply project-specific knowledge. You must evaluate the implications for all parties, interrogate the data, and most importantly, provide reasoned strategic advice to the employer before a change is formally instructed.
Part of being that strategic advisor is knowing the fundamental rules of project dynamics. And one of the most critical rules highlighted in the guidance is all about timing. The later a change occurs in the project lifecycle, the more it costs, and the more it disrupts the critical path.
Always.
If an employer changes a specification during the feasibility stage, it's just a few keystrokes in the BIM model. But if they change it after the contractor has already procured the materials and started installation on site, you are paying for wasted materials, demolition, remobilization, and entirely new supply chain lead times. The opportunity to influence the project decreases, and the cost of making a change increases exponentially as time goes on.
Which is why evaluating the why behind a change is perhaps the most important advisory role you play. Before implementing any change post-contract, you have to interrogate the impetus. Is the employer asking for this change to achieve a quicker build, allowing tenants to move in earlier and generate rental revenue? Is it for improved performance, like upgrading the HVAC system to lower long-term maintenance costs? Or is it simply a reactive cost-saving measure?
And what happens when the change isn't driven by the employer at all? Because often, the contractor initiates a change to cover up or fix a problem their own supply chain created.
This is where your granular knowledge of the contract protects the employer's budget. If a contractor's team has to rip out and replace poor quality work done by their own operatives, that is absolutely not a change the employer pays for, even if it alters the timeline.
Right.
Under NEC contracts, this is termed a disallowed cost. In JCT or other forms, it is categorized as a defect or a non-recoverable cost. As the strategic advisor, you must rigorously enforce the contract to ensure that the cost of fixing a contractor's failure is borne entirely by the contractor and not quietly passed on to the employer under the guise of a design variation.
So, what does this all mean when a project faces a barrage of minor tweaks? We've all seen projects that suffer from death by a thousand cuts.
Oh, the worst kind of projects.
The employer keeps tweaking the design, moving a door here, upgrading a finish there, changing their mind week after week. It seems harmless to them in isolation, but cumulatively, it creates absolute chaos on site.
It is a massive commercial and legal risk. I once reviewed a commercial fit-out project where the employer changed the paint color of the main lobby 6 different times.
6 times.
6 times. To the client, it was just a minor aesthetic decision. But practically, it disrupted the scaffolding schedule, which delayed the flooring contractors, which pushed back the commissioning of the fire alarms. The delay ended up costing 10 times what the actual paint cost. When a project faces excessive changes like that, you run the risk of contract frustration.
How does frustration work in a legal sense on a construction project?
Frustration occurs when the original intent and scope of the project are so fundamentally altered by continuous changes that the original contract no longer reflects the reality of the work being done. The baseline schedule and rates become completely meaningless.
So the contract basically breaks down.
Exactly. In severe cases where the scope is drastically altered by numerous massive variations, it may actually necessitate the creation of a separate collateral contract. This is an independent agreement that sits alongside the main contract, legally acknowledging that the new work is so far outside the original scope that the original terms, rates, and timelines simply cannot govern it fairly.
That sounds like a legal, administrative, and commercial nightmare that every single party involved wants to avoid.
It absolutely is. And that is why rigorous change management, not just rubber stamping the control documents, but actively managing the site impact, is essential. You have to evaluate the cumulative impact of changes. You cannot just assess a variation in a vacuum.
Right, it all connects.
If a massive amount of work is omitted from the scope, for example, you might need to strategically negotiate increased rates for the remaining items so the contractor isn't financially ruined by the reduced volume and lost overhead recovery. You have to look at the whole board constantly.
This has been an incredibly dense and rewarding journey through the mechanics of construction change management. To summarize the essential strategies we've uncovered today, first, internalize the difference between the strict, formal mechanics of change control and the strategic, site-level execution of change management.
Second, know your contractual terrain perfectly. You need to know if you are dealing with the separate time and cost tracks of JCT, the holistic, proactive compensation events and early warning notices of NEC, or the engineer-led rate adjustments of FUDI. Third, leverage your tech advantage. Use BIM to automate your quantity takeoff so you can spend your time negotiating the rates and logistics rather than arguing over geometry. And finally, maintain a robust, mathematically sound risk register to protect your contingency, always keeping in mind that the later a change happens, the harder it hits the bottom line.
This raises an important question for you listening right now. Think critically about the projects you are managing today. Are your current risk registers actually driving your daily commercial decisions, shaping your contingency calculations, and prompting proactive early warning notices? Or are they just a compliance document sitting in a drawer somewhere, waiting for an audit? That is the perfect operational challenge to leave on. And to build on that, I want to leave you with one final provocative concept to mull over. We've talked today about how building information modeling automates the geometry and the math of a change, updating the QTO instantly. But imagine a very near future where predictive artificial intelligence is directly integrated into these standard contract platforms.
That is a wild thought.
Imagine a world where the software doesn't just calculate an NEC compensation event or a GCT variation after the fact, but autonomously analyzes weather patterns, global supply chain lead times, and live site progress data to predict a failure before it happens. What if the AI automatically drafts the early warning notice and begins negotiating the time and cost parameters with the other party's algorithm before a human being ever steps foot in the site cabin? When the mechanics of change control are entirely automated by AI, how will your role as a professional pivot? How will you transition from calculating the change to strategically commanding the algorithm to protect your client? It is coming much faster than the industry thinks. Thank you for joining us on this deep dive into the architecture of project management. Until next time, keep anticipating the risks and keep managing the change.